negative there as part of your GCF. The next thing you look at is you look at the first variable, x in this case. Now you need to have an x in both positions. Now you don't over here on the right, but let's just say you did. Let's just say it was yx for the moment. You would look for the smallest exponent, okay? And that's
Okay.
what you would factor out. But this one does not have an x in both, so you ignore it, you move on to y. What is the exponent of y?
1.
In both cases, it's 1, so the smaller one is 1. You can write it if you want or not. So now the question is, well, what do I do next? What do I write next here? So there's a couple ways to do it. The faster you get, you'll just be able to write it here. If you're not sure, though, you can divide both of these by the greatest common factor. Okay. Is this something you've seen before or something you're comfortable with?
Yeah.
Okay. Can you tell me what goes here in parentheses?
The factor of 4x cubed y.
So
What's
the
left?
yeah, I'm asking you what's left over in parentheses after you're done. If you know, if you don't, we can go through it.
Um, 2x cubed
Good.
plus
Take a
or
look at the
minus
sides.
3y.
-3. Okay. Not 3y. So sometimes it's good to kind of do this division. See how the y's cancel, and then there's no y's down below. The y's cancel. You said that correctly, and then you deal with the signs here. All right. Any questions on that? I'd like to give you another one to try here, but anything unclear about this one?
Um, no, I understand that.
Okay, let's try another one here. Let's go -9x squared y plus 15xy squared. Okay, so I want you, after you've written this down here, to look at the numbers first. Sorry about that. Let's get that framed better. Okay, you're looking at 9 and 15. You got to find the greatest common factor between those two numbers. What is that?
-3.
Yeah, and it's a preference to bring out the negative. Good. So I like to write that on the outside. Now between x squared and x, which do you choose?
Just x.
Just x to the power of 1. You choose the smaller exponent. It's similar to the GCF, but it's a little, use different language with variables. And how about anything else here for a GCF?
Y.
Yeah, y to the power of 1. So again, if you're unsure, again, what I recommend is dividing each of these by the GCF until you're super solid on how to do these without it. Can you tell me what goes in parentheses?
3x minus 5y.
Good. Very good. Now, do you have more complicated problems than this that you need to work on, or did you move on to other types of factoring? Give me a little more information about what you guys are working on, please.
We also did like -12x cubed plus 30x squared minus 16x plus 40.
Okay. So more terms.
Yeah.
Okay. All right. Now, have you just started factoring, or have you gotten up to things like x squared plus 5x plus 6? Have you seen anything like that yet?
We've done one like 4p squared plus 36p plus 81.
Okay, you're doing perfect square trinomials. Okay, got it. All right, let's do a couple more of these. Is this one that you need to work on for your assignment, or just
Yeah.
one that you gave me? Okay. All right, very good. So this is something slightly different. So so when you think of, let me make one more comment here. So on GCFs, this is always the first type of factoring you do. So no matter the problem you get, you always do GCF first. You always look for GCF. And students often forget that, and they make the problem more complicated than they need. Okay, so the next type of factoring that I saw on this sheet is what's called factor by grouping, or on your what we're looking at there, factor by grouping. So you gave me a problem like this, okay? Now, how do I know that it's factor by grouping? Well, there's 4 terms. That's usually a good indicator that it's factor by grouping. I think this is factor by grouping. We'll know in a second here. You do have to look and see, well, is there a GCF between all four of these? And I know, for example, that 2 goes into all of them, but is there a bigger number than 2 that goes into all four?
No.
It doesn't look like it. I'm even going to factor out a -2. So that's 6x cubed minus 15x squared plus 8x minus 20. All right. So this -2 is actually kind of a distraction, but we're gonna go from here. So I'm actually gonna reframe this where I just move this out, and we'll look at the rest of it. We'll bring that -2 down later. So factor by grouping, you look at the first two terms, and you find the GCF just with those first two terms. What would that be?
3 or 3x squared.
Yeah, 3x squared, and then inside parentheses here is 2x minus 5. Now, this is the part that's kind of unclear for students, but you immediately take this part here, this 2x minus 5, and you write it over here on the right. Have you seen that in class?
Yeah.
Okay. Now, it's kind of a guessing game. You're like, what do I put here in this middle position such that when you multiply in, you get back to the previous line? It's usually best to look at the constant. Like, what do you multiply 5 by to get back to 20, or minus 5 to get back to minus 20?
4.
4. Now, here's the thing. It's got to work for both. Like, even though you tried it for this one, it's got to work for the other one. So 4 times 2x is 8x. That's good. If it doesn't work, you've either made a mistake or potentially it's prime. You're probably not going to get too many prime problems here in the start. So this is factor by grouping, but we're not done. And I actually prefer calling it double factoring because you always factor at least twice. Okay, we're not done here. Notice that each term down here at the bottom has a 2x plus 5 in it. Okay, which means we can factor out the 2x plus 5 from both. What's left over when I factor out a 2x plus 5?
3x plus 4.
3x squared plus 4. Yep. And those go in the other set of parentheses here. Okay. Maybe you're already way ahead of me here, just giving you the full explanation. Don't forget to bring the -2 down. But that is it. That is a factor by grouping problem here.
Okay.
So what I'd like to do is give you look at least one more of these with you before moving on to something else. You can either give me one, or I've got a bunch here if you want me to choose one myself. What would be best for you?
I don't think I have any more of those.
Okay, so let's look at another factor by grouping here. Just a moment. All right, so I'm just grabbing a snip from another worksheet that I've got, and I'll snip in this question. Are you in an honors class or any sort of distinction in your math class?
Honors.
Yeah, could tell you're doing some more challenging stuff than the average Algebra 1 student. Okay, so this is a factor by grouping problem. Now I'm telling you that, but if you didn't know that, you would look at this and say, oh, it's got 1, 2, 3, 4 terms in it. That's one of the giveaways that it's factor by grouping. Is there a GCF in this problem?
No.
There is not. Okay, so you start by looking at the first two terms here. And what is the GCF between those two?
X.
X. Okay, so what goes in parentheses?
X plus 2.
Good. And you immediately write that over here to the right, leaving a space. And we got to figure out what's going to fill in that space. What do you multiply
Y.
in? Yeah, y. You got it. And it's plus y.
Yeah.
It's not just a y. You got to put an operator there. And so this is the part where you probably picked up on this right away, but there's always this like thing that's shared in both. So it factors out again. That's the double factoring part. And then you write what's left over, the x plus y. Any questions on that?
No, I think I understand that.
Would you like to do one more, or move on to perfect square trinomials?
One more.
Okay. This one's got a little additional wrinkle to it, but actually, let me not do that one. We'll do this one. I'll not get into new stuff with you. Have you heard of difference of squares yet?
Yeah.
Okay. Well, never mind. We could have done that one. We'll do this one though. All right. So we got first thing you always ask for. I know it's maybe it sounds silly, but you do look for the GCF first. Is there a GCF in this
No.
problem? No. So you look at the first two terms, n squared plus 2n. What is common between them?
N.
N. So again, it's n plus 2. You write n plus 2 over here, and you got to figure out what goes in that missing position.
3m.
3m, yeah. Plus 3m. Final answer is n plus 2 times n plus 3m. Awesome. Okay, so one of the reasons you're learning this factor by grouping is there's a type of factoring that always breaks into factor by grouping. So they're showing you this first so that when you get to that one, you know how to do it. You're going to be tested at the end of this with questions that you just have to factor. Like the instructions will just say factor, and you have to know which approach to use.
Okay.
Okay, so that's why I'm trying to tell you why this is factor by grouping, so you know. So you're like, all right, I got it.
Okay.
Now, not everything with four terms is factor by grouping, but we've done enough that are. So you mentioned a perfect square trinomial. Let's look at actually, do you have some that you need us to do, or do you want me to start snipping in questions of my own?
I think I found one that wasn't a perfect square trinomial.
We can talk
2m
about sorry, go ahead.
2m squared minus 10m plus 12.
Okay, so what is the very first type of factoring that you are always supposed to do?
Greatest common factor.
Does this have a greatest common factor?
2.
Yes. So you bring the 2 out. M squared minus 5m plus 6. Okay, so this is not a perfect square trinomial. And the reason I know, we can get into that, but you have to be able to take the square root of both the first and the last term. And I don't know the square root of 6, and nobody does on existence because it's a irrational. The square root of 6 is irrational. But this is a different type of factoring. You're trying to find two numbers that multiply to 6, but add up to -5. Okay, so you start building these lists of like, what are the types of factoring that you're supposed to know? And so like perfect square trinomial might be here, difference of squares might be here. This one is what I call a equals 1. A equals 1 refers to that coefficient there, and that's where you look for two numbers that multiply to the last but add up to the middle.
Okay.
So what I do, especially if I'm showing someone the first time, is I have you write all of them, and you say, oh, none of those add up to -5, and you're right, because they can both be negative.
Negative. Yeah.
And then you have them. It's really important to write all the pairs. Your instructor will probably give you a challenging problem where it's hard to find the pairs, and that's why it's good to know how to do this. We can talk about that if we need it. Do you know what to
Okay.
write next, or what goes in the binomials here?
I think it's m squared minus 2 and then 6 minus 3.
So you bring the m down for sure, and then you use the two numbers, m minus 2, m minus 3. And then this 2 is brought down. The idea here is that if you were to FOIL this, because you mentioned m squared, you'll see that if you FOIL it, if you were to FOIL m minus 2 times m minus 3, when you do the first, that gets you back to the m squared. The outer is minus 3m, the inner is minus 2m, the last is plus 6. Okay, so whenever you're breaking apart a quadratic, it's always a linear term. The binomials are linear. They're single exponents of m or x or
Okay.
whatever. So you've really done all the factoring. Like I'm not like there's more here. 1, 2, 3, 4. The 5 is like a not equal to 1. There are difference of cubes, sum and difference of cubes. I mean, there's a bunch of these that you're probably seeing.
Okay.
Should we do some perfect square trinomials, or do you have some other problems that you want us to look at?
Um, can we
Or
focus more on the ones that aren't perfect square trinomials?
yeah, now you're not talking about like exceptions. You're talking about problems like this, is what I'm
Yeah.
guessing. Yeah. Okay. So actually got a really good worksheet on my website, but I'll send that to you in the chat later on or by email. So there's a couple of different types. Let me grab this one here. We'll take a look at. It's kind of like the one we just did. Okay, there's no GCF. We're not focusing on that.
Okay.
What you have to identify is that this is what I call an A equals 1. And that's ax squared plus bx plus c. That's when it's just an x squared. And
Okay.
when you see this right here, it's like, yeah, even though it's a squared, it's really x squared. And if you don't like the a's, you can rewrite it with x. That's totally okay. Same thing as the last problem, though. You got to find two numbers that multiply to 32, but add up to -12.
Okay. Because my instructor said that like draw a diamond and then the first and the last term multiplied together. Um, so like
That's for these a not equal to ones.
okay.
And he's not wrong. He's not wrong. And I'm not trying to lead you down a different path, but it's like this is the right approach. Do you play sports?
Yeah.
What sport do you play? Or like
Soccer.
soccer? Okay. So you recognize the defense, or if you're a defense, you recognize their offense, and you have a different strategy based on that. I'm
Hmm.
assuming your coach talk. It's the same idea here. Like the strategy I'm giving you works when a is equal to 1, meaning there's a 1 in front of here. When there is not a 1, we do something totally different.
Okay.
And so you just like, I'd like to do this problem, but then I can show you one of these not equal to ones problems, if that's okay.
Okay.
And that diamond approach is valid. So two numbers that multiply to 32 but add up to -12.
-6 and -6.
That would be true if it was positive 36. So sometimes you got to just start from the beginning. 1 times 32, 2 times 16, 4 times 8, and that's it. But we
Okay.
want negative. We want negative, so they need to be both negative. Do any of these add up to -12?
-4 and -8.
Yes, x minus 4, x minus 8.
Okay.
All right, so let me address the thing that you were asking me about, because this is the other type that you're going to see here. So we're kind of all over the place tonight. That's apologize. Normally I would go through them in a certain sequence, but I didn't know how much you had learned. So does this have a GCF?
No.
No. This is not a difference of squares. Okay. And that's kind of the progression here. It's not a perfect square trinomial. It's not an a equals 1. It is an a not equals to 1. Okay. So this number in front tells me that type. So there's this progression, and we do this when we play sports. We just don't think about it. It's like defender there, go right, nope, go left, whatever the options are. We know to do this, but in math we build these algorithms or these recipes. So when you get this, you take the first term and the last term and you multiply them together. 2 times -14 is -28. Now you need two numbers that multiply to -28 but add up to -3. So let me build that list for you. It's 1 and -28, -1 and 28, 2 and -14, -2 and 14, 4 and -7, -4 and +7. And
Um,
it's generally the case that you kind of have to get to the end to get it, but
4 -7, I
right.
think.
And here's why you do that. You take 4 and -7 and you break the -3n apart, okay, which is different than what we did in the previous problem. So that -3n becomes 4n minus 7n. And then you bring the other two down.
Okay.
Now, why would you do this is maybe a question you might be asking yourself. Sorry about that. Let's get that up. Well, this is factor by grouping. Remember earlier I said there's a reason you're learning this factor by grouping. It's
Yeah.
because you break apart these a not equal to ones into factor by grouping.
Okay.
So that's why we learned it. So now it's like, okay, what's common between 2n squared and 4n?
2n.
2n. Good. What goes in parentheses?
N plus 2.
N plus 2. So you immediately write that over here, and you got to figure out, well, what goes in here such that when you multiply in, you get back to the previous line. I would look at the constant. What do you multiply 2 by to get back to minus 14?
-7.
-7. That works with the n. Okay, and then we've got it. So it's n plus 2 times 2n minus 7.
Okay.
All right, so we're actually so the try it out thing we're doing tonight. I've got another lesson here shortly. I wanted to